Just to recap, a linear expression is an expression where your term with your variable has an exponent of 1. The exponent says take your variable and multiply it by itself this many times. Well, if I have a 1, I'm not multiplying my variable by anything. It's just the variable. So it is redundant to write the number 1. So we don't write it. Just like we do not write the number 1 in front of parentheses in expressions. Just like we don't write the number 1 in front of a variable that has a coefficient of 1. It is implied that it is there. It's called invisible math. So today we're going to talk about combining linear expressions, but combining them through subtraction. So we're going to subtract two linear expressions. To remove our parentheses, we have to multiply through by a positive 1. So we're going to start that with the first linear expression, 5p minus 7. When I multiply through by my positive 1, I end up with 5p minus 7. So now I'm going to take the second expression and I'm going to subtract it from the first. So instead of multiplying through by a positive 1, I'm going to multiply through by a negative 1. So we have to remember when we multiply or divide with our positive and negative numbers, we need to have a special trilogy of a negative number, and a positive number in our expression. So if I'm multiplying through with a negative and a positive, my answer, my product, has to be a negative number. In this case, a negative 3p. So now I'm multiplying through a negative times a negative. My answer now has to be a positive number. So negative 1 times a negative 2 is a positive 2. So when I'm subtracting a linear expression from another linear expression and I distribute, I am changing or taking the opposite or the inverse of whatever's inside my parentheses. So 3p minus 2 is now negative 3p plus 2. I'm going to rewrite my expression so that my variables are together and so that my constants are together. So now that my expression is rewritten, I'm going to combine my variables and figure out the net value, 2p. I'm going to combine my constants and figure out their net value, negative 5. So when I subtract the two linear expressions, I'm left with 2p minus 5. In this example, I have a coefficient in front of my first linear expression. So I need to distribute negative 2 to everything inside of my parentheses. So negative 2 times 3x, we have to remember our trilogy of a negative, negative, and a positive. Negative 2 times positive 3x is a negative 6x. Negative 2 times a negative 1 is a positive 2 because of our negative, negative, positive trilogy. So now I'm up to my second linear expression. I don't have a coefficient in front of my parentheses, so I'm going to remember that I have a negative 1 out there. Whenever there is not a coefficient or whenever there is not a number outside the parentheses, that means there's really a 1 there, or in this case, a negative 1 because of that subtraction sign. So I'm going to multiply through by a -1. A -1 times a positive 4x is a negative 4x. A -1 times a positive 1 is a -1. And I'm going to rewrite my expression grouping my variables together and grouping my constants together. Now I'm going to take the net value of my variables and the net value of my constants, and that is my expression, -10x plus 1. One last example. Again, there is no number outside my parentheses, so I'm going to remember that there is a positive 1 out there. I multiply through by the positive 1, and I get 2p plus 7. For my second linear expression that I'm subtracting, I have to remember that that is a -2 that has to be distributed to everything inside the parentheses. So -2 times a positive 2p is a -4p. -2 times a -3 is a positive 6. The commutative property of addition says I can move my terms around and group them with like terms together. So my variables come first, followed by my constants. I figure out the net value of my variables, and that's -2p. And the net value of my constants is a positive 13, and that is my answer.